and I certainly have some questions. And I would start, Sohail, if I may. I'm very interested in, you mentioned on your triangle there in the beginning of your presentation, model-based anything. And I find this super interesting because I remember there was a very interesting proof of concept by Arup developing a human digital twin using BIM software. And then they did that. They developed a human digital twin, a human BIM, if you like, not quite a digital twin as a prototype. And they proved that that was possible in and for me that was interesting mainly because Revit is a pretty difficult modeling tool. It constrains your modeling in all sorts of ways. And to design things that are double curved or have very complex geometry is very tricky in Revit, even nowadays. And then you propose a model-based anything, like I suppose coming from model-based systems engineering framework. And I just wonder, when you say anything, what do you mean? It would encompass, of course, urban systems, but what other systems are you thinking about?
We actually have in urban systems, as you know, we are dealing with different type of systems. It's a very complex system, A, and B, we are dealing with the built infrastructure, natural infrastructure, and human dimension. So when we talk about the model-based anything, we are talking about these three dimensions. So in our lab, we are in the built environment. Certainly, that is the easiest way because you are able to use the model-based, system engineering to run the model and then evaluate that. The natural environment is getting a little bit more complex because you are dealing with the physical aspects and the natural features like the Earth's observation aspects, which are physics-based phenomena and dynamic phenomena, and we should be able to adopt the reduced order model to be able to run analysis to see the behaviors, things related to the temperature or pollution movement and so on, and the impact of the vegetation and land use and so on. So this is, again, doable, and we do that. Then it comes to the human dimension. We are dealing with the social dimension. We don't, at least in our lab, we don't focus on the individual human dimension, but is more on the demography and the social aspects. And we use agent-based modeling for understanding what is the dynamic behavior of the agents in different urban settings. So although, as you could see, we are right now we are working on the autonomous vehicle and the human, but that is the work that we are trying to do even with the psychologists or visualization team to be able to create an avatar of the human and adding some behavior from their dimension so that we can actually extract those aspects in the lab environment before being implemented.
Right, yeah. But do you consider, so I'm just trying to understand if you consider the physical world and the knowledge that can be described from the physical world, like, for example, the knowledge that you can derive from ontology, like the BFO, like the physical, actual bits and bobs of the planet and of the physical reality, etc. Or if you consider more like abstract systems, like, for example, the financial system as it operates, or some cognitive systems, when you're talking about model-based anything. For me, it seems to be more along the lines of the BFO, the physical systems we see in the planet. I mean, would you be modeling that more abstract layer of financial systems, cognitive systems, human interaction systems and so on.
Yes, this is a very multi-scale type of aspect. So it can be going down to the more close to reality and using the physical world with the reality capture and then adding human behavior into that, to more abstract type of models. And that is really what I've done as my PhD back in 2010, 12 about the gentrification. And that is, again, another model that you can see the human and politic and also that economic impact on the human behavior. So it can be in that level of abstraction as well.
Interesting. And let's see if there are any questions popping up here. No, I think people are very shy today. They're very quiet. But I have another question. I promise to be the last one. I'm noting the time. And it's about your mention of quantum computing and how you see quantum computing in relation to urban systems and GeoAI, digital twins. Where do you think, or how do you think the value streams will consolidate? Where is the value coming from of adding quantum computing to GeoAI, digital twins?
Many urban phenomena, specifically urban physical phenomena, are very computational extensive. And what we do right now, I mean, dealing with these computational extensive type of models, we try to reduce order model or ROM. So, and then we try to use as much as artificial intelligent, algorithms possible to represent that, but still we abstract them. So quantum computing is really very powerful in this case, specifically when it comes to the natural hazard and hurricane in our area, how it really impacts the entire region in different timeframes. And that is where we feel that and right now we are working with our colleagues in the engineering to be able to bring that power of quantum computing to better represent the urban phenomena in our cases.
Right. And any framework you recommend? Because Microsoft came up with something really amazing last year, and then this year Google came up with something even more amazing in terms of what in essence building hardware, like building microchip architecture, computational architectures for quantum computing. Is there anything in particular you using or testing that you recommend if students or people in the industry want to play with that?
Apparently, this is not my area. So I actually just I refrain to say anything about but I think this is an area that we are working in the digital engineering team, and we are trying to bring that up into this. But I can actually help with the connection to the Digital Twin Consortium, and we have a group, a working group there, which is a digital engineering working group, and there are a number of standards written there, specifically. Although those are not for urban areas, mostly for defense and aerospace, but it can be some applications there, and most of them are openly available to public.
Fantastic. Yeah, no, that's super interesting. I'm very interested in this because at UCL, I do lots of research on blockchain and the cryptography challenges that quantum computing represents is very impactful on blockchain development. And I know that there are like a quantum cryptography being implemented, but this is going to be good moving forward. But looking back, quantum computing represents a risk, a very big risk.